Good day, this is Sergio. I'm an AI consultant for EPM Systems, and today we'll be doing a demo on the Microsoft 365 Copilot Retrieval API. The Copilot Retrieval API's main advantage is that it allows you to make RAG retrieval over zero copy. So that means you're making it over the same elements that Copilot uses to retrieve information over the same chunks. There's a nice interactive demo at the website that you can play around with. So it will show you how different products from Microsoft work. So you can do doc search over the Graph Search API. There is an endpoint for a search API to bring over documents. And the one that we will be looking at today is the Copilot Retrieval API that brings chunks from the resources in your OneDrive and your SharePoint. So it can be very convenient, which is actually one of the points. Um, so essentially, you can retrieve the latest content from your SharePoint or OneDrive. You have the Copilot Premium license. You always get the latest results, and you don't have to make any data pipelines over SharePoint, which is, I think, a great advantage if you want to move fast. With that context, I just want to show you a quick demo we set up. Um, we'll be looking at a few links that we've generated for a couple companies. So one of them is Quantum Next Systems. This is all fictitious, right? So it gives you a few context for this company, and this is a PDF over a different company that we'll call Green Grow. So now we'll see what these two are about. Uh, so again, I will um, run this with a couple examples I have prepared. So what the architecture for this is very simple. I have a long chain agent over color to the retrieval API, and you can see it will authenticate using my Copilot subscription. I've got a premium subscription, but there's a few pricing models. You can also do pay as you go. I think if you do pay as you go, you lose the OneDrive, but other than that, you can still connect to SharePoint. So it's still convenient. Okay, so I've authenticated. It knows I have Copilot Premium, and here's the SharePoint path for the site that I was just showing a few seconds ago. So now I wanna ask, okay, what does Quantum Next Systems do? Okay, so to make this demo a bit more comprehensive, wanted to show what the retrieval query is doing. So here it goes. It found the right document, right? This maps to the right document at my site, and here's the snippet that it extracted. Um, and This is the chunk. It's 85 0.85 relevant. And with that, the agent now can come back and tell me this answer. Quantum Next Systems is an artificial intelligence and intelligent automation company. It does machine learning, digital transformation, cybersecurity, and quantum-oriented computing. If I go to my document, what's actually quite good is that these um, information is across several pieces on the document. So you can find the artificial intelligence and intelligent automation piece here, and digital transformation is in this other paragraph. Um, and then you have cybersecurity here. So as a rack system, I think it's doing well. I'll test another query. Um, I have another example that I did on the Echo Harvest system, which is another product that's listed in one of the documents of this repo. So let's give it a go. Okay, cool. So again, it brings a few chunks that it thinks are relevant. Um, right, we have the page one. This is mapping to the PDF we were seeing earlier. And okay, so it's a sustainable farming approach that combines eco-friendly agricultural practices with smart technology. It has precision irrigation, organic nutrient management, biological pest control, and sensors, right? So I have my source right here, which is very convenient. Again, I can go now and navigate that source. So this is the one. Here you see the features you were listing on the other page. So as a rack system, I think it's very convenient. Uh, Pricing is, I think, if you have the Copilot add-on license, it will run it at no extra cost. If not, you can use a pay-as-you-go um, license. I think it's 10 cents per API call, which I mean can be a bit pricey, but it's convenient if you're looking for a quick start and you want to avoid any data pipelines, or you always want it's a few documents and you always want the latest information. I think it's a solid choice. So that's it on my end. Thank you.
Thanks, Sergio. Hi, everyone. I am Juan. I am a data scientist inside EPAM Systems. And in the previous part of this presentation, our colleague Sergio showed a demo of the application, including what the application can already do from the user's perspective. So he walked us through the SharePoint environment and showed the documents that are being used as the source of information. So in this part, I'll focus on how the application was built and what happens behind the scenes. Let's start with the architecture. And as Sergi demonstrated, the user can ask questions about the information stored in SharePoint. And behind the experience, the application has several components working together. First one is the Microsoft Entra ID, which handles the authentication and provides the access token. So it helps also with the delegated permissions as well. Second is the SharePoint, which contains the documents and the enterprise content that we want to search. The third component of the application is the Microsoft 360 Copilot Retrieval API, which retrieves relevant information from SharePoint. And the fourth is LangChain, which provides the agent and exposes the retrieval functionality as a tool. And finally, an LLM configured through the Azure Chat OpenAI, which uses the retrieved information to generate the final response. Okay, so the application is implemented in Python. For authentication, we use the Microsoft Authentication Library, or MSAL. And for Microsoft 360 Copilot, the application uses the library, the SDK, and Microsoft agents, and 360 Copilot. For the agent layer, we're going to use LangChain, and for the language model, we're going to use Azure Chat OpenAI. So let's look at at the identity component, which is the Microsoft Entra ID. And the code of our application is going to expect a tenant ID and a client ID, which you can acquire from the configurations of your application. And also, we're going to be using delegated permissions, where you can obtain from the configuration of the app. For the purpose of this tutorial, of this demonstration, we're going to be using just two files, read all. I'm just going to give it a little bit of zoom. Files read all and sites read all. And these permissions are going to be used to access the files and the SharePoint content required by the retrieval scenario. So from the Entra ID perspective, the important pieces are the app registration, the tenant ID, the client ID, the required API permissions, and the appropriate user or administrator consent. Right? Okay, so we're going to be entering the application, and the other important component of the application is the authentication flow. This authentication flow is encapsulated in a class called MSAL token credential, and this class acts as a bridge between the MSAL and the Microsoft 360 Copilot SDK. So when the application needs an access token, it first checks whether there is an existing account and tries to acquire the token silently from this block of code. And if there is no valid token available, the application starts with an interactive authentication flow from this part. The application also is maintaining a local MSAL token cache, which you can check it out in here. And this allows the application to reuse the authentication state when possible instead of asking the user to sign in every time. And the get credential function is responsible for creating the MSAL application and returning the credential that will later be used by the Copilot SDK. Next, we're going to be using the retrieval, the connection to the SharePoint, which is included inside of this inside this function we're having here. And Sergio already demonstrated what happens from the user's perspective, and when we ask a question and we get information from the SharePoint documents. And here we can see how the retrieval actually happens in the code. It creates a retrieval post to request body, which uses several parameters, for example, the maximum number of results acquired or retrieved from the database, and the query that we're asking to the Copilot API. Also, the applications requests metadata such as the document title and the author. And here inside of the filter expression, we're going to be using the SharePoint path related to the path inside of the SharePoint that we're going to be using to retrieve the documents. Right, so this is the point where the application connects the user's questions with the SharePoint's knowledge that Sergio showed us in the demo. Okay, next we're going to be showing the retrieval AI, the retrieval to the AI agents inside of this function. So once the retrieval API returns the relevant content, the next question is how does the information get to the LLM? So this is where LangChain comes in, because the build agent function creates the agent. Inside this function, we define a tool called search SharePoint, which is here. And the tool receives the user's query, calls the Copilot Retrieval API, and converts the return extracts into the next chunks. Each chunk also includes the source URL. So the agent is then instructed to use this tool before answering, And the system prompt specifically tells the agent to ground its response in the retrieval chunks and cite the source URLs. It also tells the agent not to guess when the relevant information cannot be found. So the important concept here is retrieve first, generate second, and this is the retrieval automated pattern behind the application. Here's the LLM, which is built upon Azure Chat OpenAI, and the temperature is set to 0, which makes the model behavior more deterministic for this knowledge retrieval scenario. And the model and the search SharePoint tool are then provided to the LangChain agent. The final piece is the user interaction, which is surrounded by the chat loop function, continuously waiting for a question. So when the user enters a question, it invokes the LangChain agent asynchronously, and the agent can then use the SharePoint retrieval tool and receive the relevant content and generate the final question. So the user can continue asking questions until they type exit or finish, or they just ends the entire loop, which it can be done using by the control and the control C part. So this part of the code is essentially the command line interface that Sergio demonstrated earlier from the user's perspective. So putting everything together, Sergio's demo showed us the application from the outside, and the users are asking questions, and the application returns an answer based on the SharePoint documents. Under the hood, the process is first, the application authenticates through the Microsoft Entra ID. Second, it creates the Microsoft 360 Copilot SDK client. Third, it builds the LangChain agent with the SharePoint retrieval tool. And when the user is asking a question, the agent sends that query to the Copilot Retrieval API. And the Retrieval API searches the configured SharePoint content and returns relevant document structs. Those structs, together with their source URLs, are passed to the LLM. And finally, the LLM generates the response using the retrieved information as its grounding context. So the architecture separates four main responsibilities: identity, retrieval, orchestration, and generation. So to connect this back to the demo Sergio showed earlier, Sergio demonstrated what the application does and how it interacts with the SharePoint documents. This walkthrough explained how that functionality is implemented behind the scenes. The Microsoft Entra ID provides the authentication authorization, the SharePoint provides the enterprise content, the Microsoft 365 Copilot Retrieval API provides the retrieval layer, the LangChain provides the agent to orchestration, and the LLM retrieves the information to generate the final question. So that's the main architecture behind the application. Thanks so much.